Okay, everyone, division of radicals. Here we go. We are recording, yes we are. Division of radicals. Eyes up here. So we already wrote this in our notes, okay? This is a large radical with a fraction inside, okay? So when you see that, that's your ding, ding, ding clue, okay, that this is division. Now, you guys, we love this one because it's super simple. You have to simplify the numerator and the denominator separately if they do not have anything in common, okay? So we love radical 64 over 49 because both of those numbers are what? Perfect squares. So you have to take the square root of the numerator and the square root of the denominator separately. So the square root of 64 is 8. The square root of 49 is 7, and you're done. Okay? That's the easy one. Of course, as you know, it's going to get more complicated. Okay? So this is going to be broken up into 2 videos. So let's look at this one. So everyone write the next example in your notes. Okay, and we'll unfreeze it and we're going to talk about this. Okay, so one of the most important things that you can do to help yourself, okay, when you're looking at the expression is ask yourself the number one question. Put the star, put the smiley face. You know the deal. Put the star, put the heart, look alive, and smell the coffee beans. Yes. Okay. Step 1. Okay, 1. Can you simplify? Question mark. All right, so here we are, folk Roonies. Okay, we have radical 8x cubed divided by 50x. Okay, so we already know, and I haven't taught this we haven't done our exponent unit yet. So this part of the lesson, I'm going to give you a little window into the future on how to simplify variables in a fraction. But we already know how to simplify numbers because you just choose what is the GCF, what is the numerator and the denominator, both multiples of. And that would be what? 2. 8 and 50 are both divisible by 2. So watch what I do, okay? You're going to cross out that 8 and say, well, 8 is divisible by 2. So 8 divided by 2 gives me 4, right? And then 50 divided by 2 gives me what? 25. Okay? Now, put that in your hip pocket, Shazam, and I want you all to do this, right? Y to the 4th divided by y to the 6th. Just write this now on the side. Here we go. Because I'm going to teach you right now how to simplify variables with exponents in a division fraction situation, okay? So you have to say to yourself, what does y to the 4th really mean? It means y times y times y times y, and you're writing this as I'm writing it, fabulous. And so, of course, what does y to the 6th mean? Everybody do it. Y times y times y, and I'm doing this for a reason, on purpose, so that you can see how easy this is. Now, you guys, when we multiply variables of the same base, we do what? We add the exponents. So x squared times x cubed is x to the 5th power because 2 plus 3 is 5. We added those exponents. And some teachers would say, oh, well, we're dividing them now, so we should what? Subtract the exponents. Well, here's the thing about that, okay? Kids get, especially when we have negative exponents in the next unit, they get too confused, so I keep it simple like this, and I want you to think of it in this way. There are 4 y's in the numerator, and there are 6 y's in the denominator, okay? And so watch what happens. Anything over itself is equal to 1, okay? So those y's cancel out. Do that in your notes, okay? These y's cancel out. These 2 y's cancel out. And these 2 y's cancel out, leaving you 2 y's in the denominator. So what does that simplify to? 1 over y squared, okay? Because there are 2 y's in the denominator, we have 1 over y squared, okay? So take that thought process concept and now, here we are, okay? So I want you to look at it this way. We've got x's in the numerator and the denominator, but watch what happens. There's 3 x's in the numerator and 1 x in the denominator. Well, this 1 x in the denominator cancels out with one of the x's in the numerator, leaving how many x's left over in the numerator? Yes, x squared. 2 x's in the numerator. So now, you're going to take, I'm going to erase this because you should have written it down anyway because you're fabulous. Moving on. Okay, so we're going to take our simplified. Can you simplify? Yes, we did. Yes, we can. Yes, we have. So take what we have. What do we have left over in that numerator? 4x squared. Do it now. Fabulous. And what do we have in the denominator? 25. So now, you guys, why do we love both the numerator and the denominator? Because they're both what? Perfect squares. So we just have to take the square root of the numerator and the denominator individually. Okay? What's the square root of 4x squared? 2x. What's the square root of 25? 5. And we're done. Shazam. Okay? Any questions? All right. So what I'd like to do is, whoops, sorry, moving this over. And is it showing? Yes, go. There it is. Okay? I want to go over these 3 examples. So let me erase, because this looks like a mess. Okay, so you guys, we should be able to do mental math with the first one. Super easy, right? Why do we love A? Because there's a perfect square in the numerator and the denominator, right? So mental math. Adam, what's the square root of 144? What times what gives you 144?
12.
Thank you. Thank you, John Trees. Okay, and what's the square root of 9? 3. Oh boy, folks, wake up. I said smell the coffee beans. Take another whiff. Okay, and 12 divided by 3 gives you what? 4, and you're done. Are you with me? Okay, fabulous. Now, you guys, here is example B, and we're going to go over example B and example C live together. But again, you have to ask yourself, can anything be simplified first? So thank you, Mr. Green, and Shazam, that's a wrap.
Yes, ma'am.